All right, so this is it. What do you want to ask me? Yes.
What is D7 on the scenarios?
You want to do scenarios, some more scenarios? We're done with all the computer stuff. It's all easy. Okay, so think about that too. But I can go over D7. Let's share my screen. D7. Tony works for a furniture manufacturer. He's been given an assignment to figure out ways to cut down on waste of raw materials. After several weeks, where the desk manufacturer's team is working on coming up with a design that modestly decreases the amount of waste. However, he is concerned the process takes longer than is currently used. He comes up with a way to measure the efficiency of the shift, which incorporates waste, time, and resources. The next several weeks, he measures the efficiency. Some have been instructed to use the current process, and some have been instructed to use the new process. The foreman on each shift is responsible for making sure the correct process is being used. At the end of each shift, he calculates his efficiency metric and records it in a spreadsheet. During each shift, only one of two processes can be used because it's a small manufacturer. Eventually, he has efficiency data for a total of 44 shifts. He wants it to compare to their average efficiency ratings, which hypothesis test should use. So what kind of data are we collecting?
Waste, time, and resources consolidated.
So some sort of efficiency rating, is that quantitative or categorical? It's quantitative. Okay. And now what kind of a test should it be? Good question. That's the $64,000 question.
Would be the tuition cost.
Chi-squared on quantitative data? Got you again. Okay, it can't be chi-squared. What'd you say? A z-test? Do we know the standard deviation? No.
Like it's not a T-match pair. Because
it's not a T-match pair.
Okay.
So
it would be T2 sample.
T2 sample. Two sample T independent. That would be correct.
And how can you tell that? Just because it says average efficiency ratings, so you're comparing the two averages. So you just
okay, so we know it's quantitative.
Yeah.
Okay. So if it's quantitative, what are the so if it's quantitative, what are the options? It can be a Z, it can be a T, it can be a. Well, we're not doing standard deviation, so that one doesn't make sense. So no chi-squared at all. We're not. If we were measuring standard deviation, it could have been chi-squared, but we're not. Or it could be an F. Well, it's only two shifts, right? Or two. We're measuring two means, right? So really, we're down to Z or T. Okay. Now the question is, what's the difference between a Z and a T? Do I know the standard deviation? Does it say anything about standard deviation in there? No, it's got to be a T. Okay, so once we know it's a T, now it's a 1 or a 2 or a paired. Well, so Eric said that it was definitely not paired?
No.
Yeah. So only one of two processes can be used on the shift. So it's got to be independent. Yeah. Okay. All right. What else you got?
What computer functions should you know?
What computer functions should you know? You want me to write them on the board?
Yes.
So off the top of my head, norm as dist, norm as inverse, t dot dist, and then whether it's right, left, or 2, t dot inverse, right, left, or 2, f dot dist. Theoretically, you could use f dot inverse. I don't think so, though. I don't think I'll ever ask that. Chi-square. Does that one have period? I don't know if that one has periods in it. Chi-square dist, it's something like that. Chi-square inverse. I don't think you would need that, but you could. Is there any others?
You got like
Correlation.
Oh, choral, there's a good one. Choral, standard deviation, average. Medians, max, min, binom dist.
Quartiles?
And that one you'll need to remember if it's true or false. Remember, that's the one that, most of these are true, but that one's the one that could be false.
What's the difference with that?
What's the difference on this one?
false is if you add, you know,
It asks you, do you want the cumulative distribution function? So yes is true, no is false. Oh, I can, that's not very well. The quartile function, no, it's just plain old quartile. That's the one that I usually use.
What's that one for?
depends what
Five
keyword,
number somewhere.
Q3 keyword tries to do a false.
What is the binomial equivalent to one?
What'd you say?
Why, how we use binomial? What we get from given.
So if it's a binomial, you use binomial? I don't understand your question. I guess it's a binomial distribution. Are there any others that I'm not thinking of? I think that's most of them.
Is the test all multiple choice? Paper test is a multiple choice, and then the last two were like free responses to the scenarios. Not necessarily.
Not necessarily. It could be multiple. I mean, I'm sure there will be some multiple choice on there. There'll be some show your work. I'll probably put at least one hypothesis test on there where you got to do the whole thing. Probably won't put more than one because it'll take too long. I'll give you the long stuff for the written or the computer test.
How long's the Excel test to be? Have you written it yet?
I have not written it yet. I think somebody took 5 hours on my test. That sounds familiar to any of you? It's probably Ashley. She likes to take her time on those. Was it you?
No, but I have a question.
Okay.
Do you have previous finals, Excel finals that you could post on Canvas and things like that?
But I mean, all your tests are really good. So, except for exam 2, which we can't remember the password. Maybe I'll try. Maybe somebody in my other class got it. I'll try to
I
post
think I
that.
have it.
You do?
Yeah.
Let me hit pause. Okay. What other questions do you have? Yes.
So the function was inverse and dist.
What's the function? What's the difference between inverse and dist? Dist gives you
P-value.
p-values. Inverse gives you,
Z-score.
well, it could be a z-score, a critical value. Z-score and F-score, whatever. Chi-square, whatever. What else?
Is the F sub I equation only that we're supposed to remember?
Say it again.
Is the F sub I equation only what we're supposed to remember?
Oh yeah, the F sub I equation. You need to remember that one. I minus 0.375 over N plus 0.25. And your degrees of freedom, we got 3 degrees of freedom formulas, right? Depending on what it is. N minus 1 is for most t distributions, right? N minus 2 is for, it's also a t, but it's for slope. And row minus 1, column minus 1. That one is chi-square.
What about We're not gonna use it.
F is also an n minus 1, isn't it? Oh, actually, let's think about this.
I think it's a super weird one.
No, F is weird. Yeah, you're right. That's not that one. F is n minus 1. No, is that right? It's no, it's your number of samples minus 1
N minus K.
and n minus k. N minus k is the second one, right? It's k minus 1 and n minus k. That's what it is. K minus 1 and n minus k. Pretty sure that's right. Yeah, that's right. Where k is your number of samples.
And the k minus 1 is the numerator and the n minus k is the denominator, right?
Yeah, k minus 1 is the numerator, n minus k is the denominator. Yes?
Does that only apply to the amount of testing, or does it apply to the first step?
It applies to all F tests, which one is the ANOVA, what's the other one? Isn't there two of them?
The other one is 2 population standard deviations.
2 population standard deviations. Except for with 2 population standard deviations. You don't have a K, is K is always 2? I don't remember that one, I'll have to look that one up. I'll look that one up really quick. Do we know what the next chapter that came out of? Oh, here it is, I just found it, 11.4. Oh, no, so for population standard deviations, it's N1 minus 1. And N2 minus 1. That's what it is for the population standard deviation. For 2 population standard deviations. So basically N minus 1 for both of them. What other questions? I gave you all the questions for the hypothesis test, right? You know all the questions? You might not know the scenario, but you know the questions.
Were there any other equations that we needed to remember that weren't on the sheet?
I don't think so. I think that's it. Your degrees of freedom, that's going to be your hard one. And S sub I think that's it. And the only reason you have to memorize those is because they're not on your sheet. Huh?
So
The degrees of freedom are?
Yeah.
Oh, they are?
some of them.
So, you know,
Yeah, some of them, not all of them. Okay, just memorize the ones you got to memorize. Okay,
When do we use the F sub I?
do I dare ask if you guys know how to make a histogram? Or are you guys going to scare me?
Who did that last time?
We did that
Can't
last
do it
time?
the easy way. Do you know that?
Huh?
Can't do it.
Can't do it the easy way.
The easy way is the best one.
It's not too hard.
No, it's not.
You just do a bar graph and then go to
Find
D
them
or
all.
whatever, and then you just smush them,
Yeah.
smush them together.
Yeah, create your table manually. You'll do a better job than Excel will. Some of you will. And then bar chart, and then quick layout, and you make them touch. Okay. And remember, you heard what? When do we use this? When?
Yeah, I think.
Well, answer. QQ plot, right? Sean?
For the binomial, like, would it tell you, make a binomial graph of this data kind of thing, or?
I could. Yeah, I could say, yeah, I could ask you to make a histogram for binomial data.
Is that like with the probability stuff?
With the probability stuff
Is that what that's referring to?
for the histogram? Yeah. So that brings up a good question. So if I ask you to create a histogram for binomial data, and you wanted to use this command, would you use true or false for the table?
Say the question again.
If I asked you to make a histogram with binomial data, so you'd have to create your table,
False.
would you use true or false? False. What should it look like roughly? Normally distributed if NPQ is greater than 10, right? If NPQ is less than 10, it's probably going to be quite skewed. Yes.
So what's an example of when you would use true?
What's an example of when I would use true?
You're looking for like, from the first, we have a set of data.
Say it again.
We need a set of data. All
So I'm not following what you said there. Can somebody give me a better explanation? Sean?
You're looking for like less than 20.
Yeah.
20.
Probability that X is less than some number, then you could use true. So if you're doing a binomial distribution, let's say that your n equals 50, your p equals whatever it equals 0.05, and your q equals, in this case, 0.95, right? So, and I want the probability that X is less than or equal to 20. That would be a true. Because you're looking for the sum of all, you're looking for some that X equals 0 and 1 and 2, all the way up to 20. So you want the cumulative distribution function.
So if it was like probability that X equals 20, this is what I would
If I want the probability that X equals 20, that one is a false.
So it has to be less than 20. It can't be like less than or equal to 30. It can't be.
It could be less than or equal to 30.
That doesn't matter how many there are. It's just-
Doesn't matter. What matters is this sign here. If it's a less than or equals, it's a true. If it's an equals, it's a false. What if it's 0.0 less than? The probability that X is less than 20.
Then you do it.
Then you can rewrite that as the probability that X is less than or equal to 19, right? Then you can use true. You can always turn it into a less than or equals. Okay? How come you guys are out of questions? Man, this is your last chance. By the way, that wasn't on the board. Let me move that over there. Okay, Ashley?
We also have to find out doing like the same questions with a uniform distribution.
Oh, uniform distribution?
Yeah.
So what do you mean?
I think one thing we asked us to find the probability using the uniform distribution.
Okay. You could find the probability using a uniform distribution. You guys know how to do that?
Base times height.
Length times height. Length times width. Oh, yeah. Did you have a question?
Well, if we could ask anything, what are the answers?
What are the answers? I don't know. I haven't made them yet.
Well, when you do make it.
I'll be sure to let you know after the final, after you take it, I'll let you know. Okay? Yes.
So back to the cumulative function, so what if you were doing the numbers in between like 18 and 20, so to say, so like Greater than.
So you
18 or
want the
less than
probability that x is between 18, probability that 18 less than or equal to x less than or equal to 20?
Yeah, so would you just take the cumulative of both and subtract them from each other?
So you could do the cumulative. I would do x less than or equal to 20 minus the probability that x is less than or equal to 17.
Awesome.
No,
Yes.
it's equals to.
Because now you could do it that way. Okay. Another way, in fact, I think probably the easier way would do the probability that x equals 18 equals 19 equals 20. Do 3 calculations. Because the problem is if you put an 18 here, you're only getting 19 and 20. That's why you got to change that to 17. So this might be the easier way to do it because you've only got 3 calculations. You can do 3.
And if you are doing that one, you would use true, the top one.
These would all be false. This one, if you did it this way, that one could be a true on both.
Is there an answer key to the scenarios that you?
There's not an answer key to the scenarios. Just you'll have to ask Eric.
And hope he's right. Thanks for the vote of confidence.
Yeah, so I will say this, I have posted a lot of videos. I was surprised only four people watched yesterday's video. So there are some answers on the videos, but you got to sit through them. Okay, so yeah, watch those videos this weekend. Okay. Anything else? Tanner?
For the confidence intervals, you're asking to find an E lot.
I heard something about confidence intervals.
Yeah, it'll ask you to find like margin error.
How do you find the margin of error? On the confidence interval.
Just the critical value times by the square root of.
Yeah, so it depends on your formula. As a general rule, you're going to have a point estimate plus or minus some sort of a margin of error, okay? This point estimate is usually x bar, it's usually p hat, it's usually s. Well, we don't want to do it for that one because that's not symmetric. Anyway, so it's generally your critical value, which could be a z, a t. I probably wouldn't ask you on a chi-square because it's not symmetric. Or an f, it's not symmetric. It's your critical value times whatever's in the square root. As a very rough rule. So your margin of error depends on the formula, but that's kind of a rough shorthand for finding it. It's basically this piece here. It's your critical value times whatever is in the square root. And, you know, the square root can include a lot of things or not. Okay? All right. Don't wake up late like I did today. My alarm was, I didn't even hear it. So, yeah, it's at 7 a.m. on Monday. On the computer, you can take it Monday or Tuesday.
Tuesday.
Don't take it late. See y'all Monday.